This little video is here to talk about this guy here. This is the salt bridge of a galvanic cell, or what's known as an electrolyte inside a battery. Now, this is a cell I set up in my last video. I've got some zinc in zinc nitrate and some copper in copper nitrate. And as I explained before, the copper ions were my strongest oxidant, which made my copper my cathode. When I connect it together, I can see I'm getting a flow of electrons because they're being lost from my zinc and moving around through my voltmeter and then gaining onto my copper ions in my solution here. Now, what is the role of the salt bridge? Well, the role of the salt bridge is so we actually balance out the charge within this cell. In chemistry, most things like to be neutral. We don't necessarily see a buildup of charge anywhere. Wherever there is a gain of positive charge, there must be some negative to balance that out. We see that in ionic compounds, and we see that in a lot of other areas as well. But within galvanic cells, the idea of moving electrons around, well, without the salt bridge, that would mean that my cathode would gain a negative charge. With my salt bridge, what we do is balance that negative charge out. So therefore, as my electrons are gained here at my cathode, my positive ion from my salt bridge starts to flow towards my cathode. Okay, that's kind of how it works. The other process of my salt bridge is to ensure that we have a complete circuit. So therefore, charge flows all the way around my circuit. Now, as my electrons are being gained here, I must still continue to have a flow of negative charge around my circuit. So what happens is my electrons are gained here in my cathode, and that pushes my anions through my salt bridge back over here. So the flow of negative charge doesn't actually stop. We have negative electrons being lost moving through my wire, negative electrons being gained here, pushing away my anions through my salt bridge. So that's the two purposes of this salt bridge, or what's known as an electrolyte in a battery situation. It's to balance out the charge within a cell and also to make sure we have a complete circuit. Now, what would happen if I break this circuit? Well, if I unclip my wire, I've broken my circuit, I lose my voltage. It stops the reaction from happening. And the same happens if I lift up my salt bridge. If I lift up my salt bridge, again, I've broken my circuit and my voltage goes down to zero. So therefore, without a salt bridge or without an electrolyte, our battery simply doesn't work because we don't have a flow or continual flow of charge.